You are watching the 7.5 lesson video on cube root functions. Now, cube root functions are very similar to square root functions, only instead of finding two numbers that multiply to the number underneath the radical, we are trying to find three of the same number that multiplies to the number underneath the radical. So in exercise 1, what we're trying to do is find each of the following and justify using a multiplication statement. I'm probably only going to justify some of them. So in A, what three numbers multiply to 8? 2. 2 times 2 times 2 is 8. Therefore, the cube root of 8 is 2. Okay? What three numbers multiply to 1? Well, 1 times 1 times 1 is just 1. So the cube root of 1 is 1. What three numbers multiplied by itself will give us 27? Well, that would be 3, because 3 times 3 is 9, times another 3 is 27. So the cube root of 27 is 3. The cube root of 0 is 0, because 0 times 0 times 0 is 0. The cube root of -1, let's think about this for a second. What times what times what is -1? Well, -1 times -1 is +1, times another -1, you got it, is -1. So the cube root of -1 is actually -1. Same reasoning for the cube root of -8. So -2 times -2 times -2. A negative times a negative would get me a positive, times another negative would give me a -8. So the cube root of -8 is -2. Now, we can really just do this all on our calculator, and what you will do is you're going to press Control the caret key, because we need to get the 3 in there as a cube root. That is not the same as typing a 3 out in front. So for exercise number 2, we're using our calculator to find these. You type it in just like that, get your answer. It's 7. We can use a multiplication statement to justify. I'm not going to, but 7 times 7 times 7 is 343. Okay? Do the same thing. Control, caret, drop the 3 where the cube root is. Make sure you type a negative, not the subtraction sign. 2744. Hit enter. That's -14. And then lastly, same thing. Here we're going to type in, whoa, that's big, 12,000, whoa. Oh, I'm hitting the down arrow. I should be using the right arrow. So 12,167, hit enter, and it's 23. Okay, so those are what we call perfect cubes. Here we are going to realize in exercise 3 that these are not so perfect, even though you're like, wait, 100 is a perfect square, why isn't it a perfect cube? Well, that's because 3 numbers times itself will never give us 100. So this is where we'll use technology to help us. Here it says round to the nearest 10th. So what do we have here? 4.6 -364, so we know that the number will be negative. So if we round it, what, -7.1, and then lastly, what's going on in here? 982, and that is 9.9. Okay, heading over to the second page of notes. Okay, so here we want to graph the cube root function. So add a graph. Same deal, we're going to type in the cube root of, instead of putting a number, we're going to put an x. Ooh, that's fun. It looks like a square root function, only it's now taken over the left-hand side of the graph. Okay, so Control T, let's fill in that table. And we need -8, which is -2. Scroll down. Come on, -1 is -1, 0 is 0, 1 is 1, and 8, well, we know is +2. -2 times -2 times -2 is -8. -1 times -1 times -1 is -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Okay, so let's graph these over here. So 0, 0, 1, 1, negative 1, negative 1, and then 1, 2, 3, 4, 5, 6, 7, 8, positive 2, and then negative 8, negative 2. And it makes this little curvy thing here. I mean, mine's not perfect, but you get the picture. This is what it should look like. Look at your calculator. And using your calculator, produce a graph to verify. Well, we already did that to fill in our table of values. So we know that we are looking good. Okay. So here's our next question. Use our calculator to create a table of values that can be plotted. It looks like, ew, what happened here? Where is our question? Ah, this should be up here. That's why we're so confused. Okay, I'm gonna add a new graph, and we are going to graph 3, the cube root, I should say, of x plus 2, all minus 4. Hey, this is a shift. This is a shift of 2 to the left and 4 down. We remember this. This is all the stuff that we've done in many of our other functions. So we've done lots of shifts and lots of shifts. Okay, so we can enter. I don't want to approximate. I hit control first. That's why I did that. There she is. Okay, so 2 to the left, 4 down. We can see that going on here. So if I hit control T, I really want to find nice pretty points, right? So see, there's our like center 3 points. So maybe I'll add those in here. So negative 3, negative 2, negative 1. So it's negative 3, negative 5, negative 2, negative 4, and negative 1, negative 3. And then what we just want to do is find the next integer value. So that's at 6, negative 2, and find it up here. Many of you can probably predict that this would happen at negative 10, negative 6. So we did part A. Let's create a graph of this. So negative 2, negative 4. We're just plotting all these points, and then it's at 1, 2, 3, 4, 5, 6, negative 2, and then negative 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1, 2, 3, 4, 5, 6. So almost off the graph, but not quite. We're going to make our cute little squiggle. And there we have it. B's done. Now C says describe how the graph you drew in exercise 4 was shifted. Well, this is what we talked about at the very beginning. So how did it change? Well, I like to compare this origin point here. It was moved over, what? 2 to the left. And 4 down, which should not come as a surprise to any of us because inside, outside, left, right, up, down. And then D says state the domain and range. Well, the great part about the domain and range of cubics, no matter what it is or where it is, the domain and the range are both the set of all real numbers. So the domain is from negative infinity to positive infinity, and so is the range. And why is this? Well, because our graph will always go to the left, farther, 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 and never will end. Same, oh, the other left, so your right is what I meant to say. So it's going to positive infinity for the domain, starts at negative infinity because it covers the entire graph. And the same thing. It may look like it's not growing very low or growing very high here, but they are. It's dropping all the way down to negative infinity because this line, this arrow keeps going down, 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 down. And I mean, we could change around this window if we want to. We can see, yes, it just keeps getting lower and lower and lower and lower the farther left we go. It never really ends, and it never has something like an asymptote like it would with an exponential function. So there you have it. Cubic functions, they don't really appear too often, but it's good to talk about them, so hope you enjoyed it.